Good afternoon. I'm Dr.M.Siva, Ramkumar, Associate Professor at SNS College of Technology. Today's topic is an important part of our subject, electric circuits and electronic devices. It's a subject we are handling. We'll be discussing on full wave rectifiers today. What is a rectifier? Rectifiers are circuit used to convert AC alternating current into a direct current DC. There are two main types of rectifiers. One is half-wave rectifier and another is full-wave rectifier. In half-wave rectifier, we use one half of the AC signal. This leads more power loss and uneven DC output. That's why in many practical applications, full-wave rectifiers are preferred. In today's presentation, we will understand how full-wave rectifier work, their formulas, their efficiency, and also comparing them with an half-wave rectifier. By the end, we'll be able to see why full-wave rectifiers are more usable in real-world electronic circuits. Now let us define what a full-wave rectifier is. It is a circuit that converts an entire AC cycle with both positive and negative half-wave into a pulsating DC output. This is much better than the half-wave rectifier, which only uses the positive half of the AC input. There are two common types of full-wave rectifier. The first type uses a center-tapped transformer and two diodes. This is called a center-tap full-wave rectifier. The second type is a bridge rectifier, which uses four diodes arranged in a special pattern. This method does not need a center tap transformer, so it is more commonly used in modern electronics. Both of these circuits achieve the same goal, converting the half of the AC input into a unidirectional DC output. This leads to higher efficiency and smoother output. We will see the formulas and performance of these rectifier in next slides. Now we will look at the basic formulas that are used to study a full wave rectifier. The full wave rectifier has a few important quantities: the average output voltage or DC voltage. This tells us how much steady DC we get, the RMS voltage and the current. These values help us to understand the effective power delivered, and also efficiency, form factor and peak factor. These formulas help us to design and test the performance of a rectifier circuit. For example, the average DC voltage is given by VDC equal to 2 max pi into V. Right? So by using this formula, we get double the output of the voltage compared to the half-wave rectifier. By knowing all these formulas to select the right components like diodes and resistor, when we build the actual circuit, we will go through each term such as peak inverse voltage, efficiency in our upcoming slides. Let's now understand peak inverse voltage or PIV and the DC output voltage. PIV is the maximum reverse voltage of a diode that can handle without getting damaged in full wave rectifier using a center tapped transformer. PIV across each diode is 2 times the maximum input voltage. This is important because if the diode cannot handle this voltage, it will break down. Now, next is DC output voltage. This is the average voltage we get after rectification. Right? So it's like the higher than the half-wave rectifier, where the DC voltage is only less. So comparing half-wave rectifier, full-wave rectifiers has both a better output with both off cycles utilized. So by knowing this PIV, we can choose diodes with proper voltage rating, and the DC voltage formula will help us to predict the output voltage performance. Right? So this is a schematic representation of a center tap full wave rectifier, which captures the positive waveform at the top and negative of negative off cycles output by D2. So D1 and D2 have been used to capture the positive and negative off cycle so that we get the average of good voltage here. So it's like we were talking about this PIV, peak inverse voltage earlier, right? Which is good when comparing off wave rectifier. A full wave rectifier has a better good PIV, right? Now we'll move on to the RMS value. RMS form factor and efficiency and the peak factor, rectification efficiency, all these were the ratio but the maximum value of output to its RMS value. So it gives an idea of how sharp the output pulses are, right? And like rectification efficiency, this shows how much of input AC power is converted to useful DC power, right? I repeat, rectification efficiency is which shows how much of input AC power is being converted as a useful DC power. This efficiency of this full wave rectifier is better than comparing to a half wave rectifier. So that when it comes to numerical value for a half wave rectifier it is around 40 and for a full wave it is around 81.2. This is excellent for many electronics projects. These parameters help us to compare different types of rectifier and select the best one to our needs. For example, for power supplies or battery chargers, this full wave rectifier is being used. Now let's see some more deeper, right? We were seeing on this big factor and the rectification efficiency of the full wave and of a rectifier, right? Likewise, we'll see on some efficiency performance of all the rectifiers, right? So when comparing the efficiency for full wave, it is around 81.2. Ripple factor is 0.4. Half wave has 1.2. So we can tell that we have some smoother output here. Likewise, the output voltage wise, we can get full higher output voltage in the while full wave rectifiers are better in many ways, they also have few disadvantages also. First, they need more components. A full wave rectifier needs either two diodes with a center tapped transformer or four diodes in the bridge. This increases the number of parts. Then the higher cost because of more components. The cost is slightly higher compared to off-wave rectifier. And then the circuit design is too complex, especially with the center tapped transformer. It is more complicated and takes up more space. Even with these drawbacks, the benefits far weight than the limitations. Especially we need smooth and efficient DC supply. So in most real world circuits, from chargers to adapters, full wave rectifiers are being used. So thanks for watching. Keep in touch.